Hi, I'm Ryan.
And I'm Tyler.
Today we're going to teach you the basic ideas of chemical equations.
And to start things off, you first need to know how to name the chemical compounds or elements.
Second, you'll need to know what type of reaction needs to be completed.
And thirdly, you need to know how to balance the equation.
And lastly, you need to know what phase each compound is in. But before we start, remember, safety first.
Now let's get down to business. And to start things off, we will teach you how to go from the compound name to the chemical formula. So let's start with sodium chloride. Sodium has a chemical symbol of Na, and chlorine has a chemical symbol of Cl.
There are 5 major ways that compounds combine into products. The first is called a synthesis reaction. This is very simple. This means you have 2 or more substances that combine into a single product. Using our example above, we will perform a synthesis reaction. Sodium has a charge of +1 because it needs to lose 1 electron to be a full octet, meaning 8 electrons. And chlorine has a charge of -1, so that means it needs to gain 1 electron to obtain a full octet. Thus the 2 charges cancel out and is written NaCl. So Na will have a charge of +1, and Cl will have a charge of -1. The +1 and the -1 cancel out, and the arrow means yield. It'll form the product of NaCl.
Now to represent this equation, I'm going to use some colored blocks. For Na, I'm going to use this red block, and for chlorine, I'm going to use this green block. And when red and green combine, that makes yellow. And the second thing you want to look at is whether or not the equation is balanced, and that means making sure there's an even amount of each element on each side. And for this equation, there's 1 Na and 1 Cl on each side, so it's already balanced.
And the final step is to determine if each compound is aqueous, solid, liquid, or gas. There's only one compound in this balanced equation, and that's NaCl. A chart called the solubility chart will help you determine which one it is. Look at sodium. Sodium is right here. And then look at chlorine. And follow that down. And that says it's aqueous. And aqueous basically means that it's soluble in water. So we're going to write parentheses AQ next to the compound.
Now let's move on to another one, where we will start with lithium sulfide. Lithium has a chemical symbol of Li, and sulfur has a chemical symbol of S.
The second way that compounds combine to make products is called decomposition. Before we learned about synthesis, and that's when 2 elements form into one compound. Now decomposition is where one compound decomposes into 2 elements. So the reactant is the combination of the 2 elements. Lithium has a charge of 1, and sulfur has a charge of 2. When you have charges that are opposite of each other, you're going to crisscross them, and this will become Li2S1, or you don't even need to write the 1. So then, when you decompose this becomes Li plus sulfur. Sulfur plus Li is Li2S.
And now we need to balance this equation. And by doing that, we need to make sure that each element has the same amount on each side of the equation. So you see that there are 2 Li's on the left side, so we need to make 2 Li's on the right side as well. And by doing that, we will write a superscript of 2 in front of the Li, and now the equation is balanced.
Last step is to see if each one is either a solid, liquid, gas, or an aqueous solution. Lithium is a solid, and sulfur is a solid as well. But looking at the solubility chart, the compound of lithium sulfide is soluble. You find lithium, and you find sulfide, and you look down, and it says it's soluble, which means it's aqueous, which means it is soluble in water. So you're going to write aqueous on the compound, lithium is a solid, and sulfur is also a solid. So to represent the decomposition reaction, we're going to use the same blocks as we used for the synthesis one. The compound of Li2S, we're just going to represent that as a yellow because green and red combine, react to form the yellow, the Li2S. So if you think about it, basically synthesis is just the opposite of decomposition. 2 elements make a compound in synthesis, and 1 compound makes 2 elements in decomposition.
Now for this equation, let's use zinc and hydrogen chloride. Zinc has a chemical symbol of Zn, and hydrogen chloride needs to be combined like we have learned earlier. And hydrogen has a charge of +1, and chlorine has a charge of -1.
So they cancel out, and they just erase, so there is no charge on either. They cancel. The next type of reaction is a single replacement reaction. This means that one element replaces another element in the compound. The element must be more active than the element in the compound. So zinc must be more reactive than hydrogen to where they can switch each other. You need to look at the activity series of elements. Whichever one's higher up, if zinc is higher up on the list than hydrogen, then they will replace each other. So zinc is right here, and hydrogen is down here. So they will replace, and it will combine into H plus ZnCl. On the periodic table, zinc has a charge of +2, and Cl has a charge of -1. So they will cross, and it will form ZnCl2. Since there are two Cl's over here and one Cl over here, you need to place a 2 on that Cl. But now you have two hydrogens, and you need two hydrogens over here. But when a hydrogen is all by itself, without anything else combined to it into a compound, it's always going to be an H2. So now we have one Zn on each side, two Cl's on each side, and two hydrogens on each side.
Finally, zinc is a solid, so you're going to put an S by zinc. And HCl is an aqueous solution. So you're going to put an AQ right there.
As shown again by the solubility chart. And ZnCl2 is also aqueous, shown by the chart. And H2, as we all know, hydrogen is always a gas.
So put a G there. An AQ there.
To represent this, we're going to have zinc as yellow, hydrogen as red, and chlorine as blue. Due to the lack of colors, we're just going to have to make do with the colors that we have right here. So when we form the products, hydrogen is by itself, so it'll be red, but then the blue and the yellow will now combine.
And now we will react silver nitrate with sodium chloride, which is AgNO3 plus NaCl.
And nitrate NO3 is just one of those compounds that you just have to remember. It's not in the periodic table, you just have to remember that nitrate is NO3. And Ag has a charge of +1, nitrate has a charge of -1, so they cancel out, so just 1, 1, or you don't have to write the ones. Na has a +1, Cl has a -1, they also cancel out. We will now do our double replacement reaction. This is our fourth type of reaction that we will be doing today, out of the 5. This means that the two ionic compounds where the positive ions change place. So basically the two middle elements, Na and NaNO3, or compounds, will combine into one of the products, and the two outside will combine. So using the charges, Na and NaNO3 will combine into NaNO3, and Ag and Cl will combine into AgCl. This equation is already balanced. There's one of everything on each side. So the full equation is AgNO3 plus NaCl forms AgCl and NaNO3. And looking at the solubility chart, AgNO3, NaCl, NaNO3, and AgCl all are soluble, which means that they're all aqueous. So we're just going to write aqueous on every one of them.
Okay, and now we will do a combustion of methane. We will use CH4 and oxygen, which is O2.
When it's by itself, oxygen will always have, it's a diatomic, so when it's by itself, it'll be O2. And then
that yields.
And that forms the product of a combustion reaction always forms the product of CO2 and H2O. And to balance this, you have to have the same on each side. But in this case, you need a 2 right here, a 2 right here, and then that's balanced. And every compound in a combustion reaction is a gas. So CH4 is a gas, O2 is a gas, CO2 is a gas, and H2O is a gas. And to represent this reaction, you really can't. I'm just going to show it with these 4 separate colors. And there is no like switching across the yield sign. Green is going to be CH4, yellow O2, red CO2, and blue H2O. So now you know how to make chemical reactions and how to form them.
I'm Tyler.
I'm Ryan. I hope you enjoyed the video.
And I hope you learned something from it.
And remember, always use protection.
Especially when you're dealing with chemicals in the lab.